then we go for the next speaker, Ricardo Ekmay. He's a senior vice president of the product development for air biome, so from the US, so it's a long way to come all the way to Rimini. And you will be talking about beyond insect flowers, so the use of wood-based yeast single-cell proteins. I will just open your... just to say also that your results have been also identified as a potentially strong interest for the industry, which was done also through the AQUAEXCEL project. So you're giving the floor into getting a bit more.
All right, thank you so much for that intro. I guess I will give you a whirlwind tour in 6 minutes. I'm actually jealous of the folks that got 8 minutes. But yeah, really a whirlwind intro on single-cell protein grown on wood. So as I'm sure you're well aware, and you're probably tired of seeing this specific graph, aquaculture is growing, which is a good thing, but we have to find a sustainable way of feeding these farmed fish. And certainly there's a desire to move away from wild catches, and that's pushed us towards terrestrial alternatives, either plant proteins or animal protein byproducts. They can be things like insect meals or other single-cell proteins, microbial proteins. But as you look at this landscape, you see one common denominator for all of these, for many of these alternatives, and that's the starchy pernicious meals. Really, everyone is fighting for, competing for that grain, that kernel, that part of that hectare that all of us are reliant on. But there's just a ton of biomass that hectare produces that is not being utilized by really anyone other than a ruminant. So with that, RBM focused on trying to tap into that potential carbon source and use that as the springboard for a sustainable protein source. It's not terribly novel. Back in the 1930s, Trout yeast leveraged on this concept, the idea that Trout yeast is very well adept at utilizing 5-carbon sugars, which are one of the predominant carbon sources within hemicellulose, so that part of the lignocellulosic substrate. But over the course of time, obviously paper mills close, there's a move away from that, but nonetheless, we have that biomass, whether it's in the form of wood, whether it's in the form of straw, whether it's bagasse, some other form, there's plenty of lignocellulosic substrates to be had. So RBM looked to tap into that, and over the course of this past decade, worked on technologies to better extract and recover the sugars coming from these lignocellulosic substrates. But on the back end, we need to make a better product as well. If you look at Trout yeast historically, it has not been all that great. So we need to not only sustainably produce a protein, we need to sustainably use a protein. If you look at the landscape right now, it's kind of all over the place for Trout yeast. A recent group looked at the digestibility of Trout yeast protein and reported only a 63% digestibility, which is quite low. Our own internal work suggests that it can go much higher, 97%, which would make it suitable for high-value applications such as carnivorous fish, so salmon, trout, sea bream, so on and so forth. So really, that's what we look to do within the AQUAEXCEL program, to try and vet our Trout yeast within carnivorous fish feeds. So thanks to our work with INRA at the Saint-Pé station, we are able to confirm our results of a very high crude protein digestibility, so 94%, and certainly distinct from what was previously reported by other groups. But we also show that it effectively replaced fish meal within rainbow trout diets and improved the performance of plant-based only diets, so diets devoid of fish meal. So throw some silver in there and you can get equivalent performance to a diet containing fish meal. So clearly we were able to expand the body of evidence that suggests that Silpro can effectively replace fish meal and be included in the diets of carnivorous fish. So who are we looking for? Certainly feed manufacturers, feed producers, those are going to be our target markets, as well as integrated finfish farmers, so anyone that's looking to lower the environmental impact of their production, and that includes salmon, trout, sea bream. One of the key benefits of this alternative protein is that it is globally approved. So you don't have to worry about trade restrictions or whether you can ship it over to the U.S. and still sell your fish there as well. And just to close this out in terms of the environmental impact, certainly everyone is claiming sustainability, but it's always good to put some numbers. There's relative magnitudes to all of this. So we did commission an LCA to look at a hypothetical plant in France for Atlantic salmon feed production in Norway. And here we see that compared to soy protein concentrate coming from Brazil, methanotrophic bacterial meal, and black soldier fly meal, that's released has the lowest climate impact in terms of kilograms of CO2 equivalents per kilo of protein. These results have been confirmed by another group out of California, not affiliated with Arbium, but they confirm the same ranking. That release is lower than both SPC as well as bacterial meal. They did not include black soldier fly in their assessment. But with that, I'm sure there's going to be plenty of questions, but thank you for your time and your attention, and I'll leave you with that.
Thank you very much. That was really interesting. Any direct questions for this moment, at this moment, or? Okay. Yeah, one question to...
I read about the yeast that it also has a slightly meaty taste and a slightly meaty texture. Did you consider this, to utilize this maybe as a base for alternative meats, alternative seafood?
Oh, absolutely. So Arbium in itself has actually 4 key markets that it's looking at, including aquaculture. The other one is human food, so meat analogs in particular, as well as non-dairy cheeses, because that umami can really bring along that same food experience, that same sensation that they're used to, that most folks are used to. Sure. Yeah, so we do have...
Just for the rest, intellectual property protection.
Yeah, so we have a mix of patents and trade secrets that cover various parts of our technology. We focus in on patenting kind of the nexus of lignocellulosic deconstruction, fermentation and protein production, as well as downstream applications, so things like meat analogs and vegan cheeses and so on and so forth. So we've kind of covered both spectrums there.